Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from derivatives, right? And here in this class we are going to find out the right hand derivative and the left hand derivative of this given function, right? So let us start. Now see, here we are given a function f of x which is equal to x divided by 1 plus e raised to 1 over x for x not equal to 0, right? And moreover, we are given this condition, that is the value of the function at x is equal to 0 is equal to 0, right? And we have to find the right hand derivative and the left hand derivative of this function at x is equal to 0, right? So we are here will make use of the definition of right hand derivative and left hand derivative, right? So right hand derivative and left hand derivative are nothing but simply limits, right? So we have to find the limit of this function at x is equal to 0, right? So the right hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? So this is the definition of right hand derivative. So here we have f of a plus h. So a is the point where the derivative is required. So here the derivative is required at x is equal to 0. So a is equal to 0, right? So we can now write this right hand derivative as the limit h tends to 0, and we have f of 0 plus h minus f of 0 divided by h, right? So we have limit h tends to 0, f of 0 plus h is simply f of h, and f of 0 is given as 0. So here we'll write 0, and here we have h. So this is the limit h tends to 0 f of h divided by h, right? So now we have to calculate this limit. So now see, here we can write the value of f of h by replacing x by h. So the right hand derivative is now equal to limit h tends to 0, and f of h is h over 1 plus e raised to 1 over h, and in the denominator we have h, right? So here we have h. So now we have limit h tends to 0, and see, this h and this h get cancelled, right? So we have 1 over 1 plus e raised to 1 over h. Now see, here we have 1 over 1 plus e raised to 1 over h, and we have h tending to 0. Now see, when h tends to 0, then obviously 1 over h tends to a very large quantity, right? So 1 over h approaches to a very big number, and we can write it as 1 over h tends to infinity, right? So when 1 over h tends to infinity, then here e raised to 1 over h tends to e raised to infinity, right? And infinity, this is a very large number. So when the exponential number is raised to such a large number, then we always get another large number, right? So here we have infinity. So now this limit is equal to 1 over 1 plus this quantity can now be replaced by infinity, that is a big number. So when a big number is added to 1, it always yield another big number, and 1 over infinity tends to 0, right? So the right hand derivative of this function at x is equal to 0 is equal to 0, right? So now let us find out the left hand derivative. Now, viewers, the left-hand derivative is defined as limit h tends to 0, and we have f of a minus h minus f of a divided by minus h, right? So this is the definition of the left-hand derivative. So again, this point A is the point where the derivative is required. So A is 0 because here we need to find out the left-hand derivative at x is equal to 0. So now we can write the left-hand derivative as limit h tends to 0, and we have f of 0 minus h, taking a is equal to 0, and here we have f of 0 divided by minus h, right? So this is the limit h tends to 0, and we have f of minus h. 0 minus h is minus h, and here f of 0 we are already given as 0, right? So this is 0. So now we have here minus h. So this is 0. So we have limit h tends to 0, f of minus h divided by minus h, right? Now f of minus h can be obtained by replacing x by minus h in this function. So we can now write, we can take this negative sign outside the limit notation. We have limit h tends to 0, we have 1 over h, and f of minus h can be written as minus h divided by 1 plus e raised to 1 over minus h, right? Now see, this negative and this negative when multiplied together becomes positive, and this h get cancelled. So we are now left with limit h tends to 0, and we have 1 over 1 plus e raised to minus 1 over h, right? So now we have to find this limit. So now in order to find out this limit, we'll adopt the same reasoning which we have used while calculating the right hand derivative. So see, h, when h tends to 0, 1 over h tends to a large number, and we can call it as infinity, right? So when 1 over h tends to infinity, then see, here we have 1 over 1 plus e raised to minus infinity, right? And e raised to minus infinity is tending towards 1 over e raised to infinity, and e raised to infinity, it tends to infinity, so we can write it as 1 over infinity. Now we have a number that is 1 over infinity, that is 1 divided by some large number, so this is 0, right? So this quantity is 0, right? So here we can now write the left hand derivative as 1 over 1 plus 0, right? So this is 1 over 1, that is equal to 1. So the left hand derivative is equal to 1, right? So viewers, in this problem, we have seen that how to calculate the right hand derivative and the left hand derivative, right? Now see, in this problem, we have seen that the right hand derivative and the left hand derivative are both finite, right? And both exist. Okay, so now the right hand derivative is not equal to the left hand derivative because 0 is not equal to 1, right? So from the theorem on differentiability, we can say that if the right hand derivative is not equal to the left hand derivative, then the function is said to be non-differentiable at the given point, right? So this function is not differentiable at x is equal to 0, although the right hand derivative is finite, it is equal to 0, and the left hand derivative is also finite and it is equal to 1, but both the derivatives are not equal to each other, right? So this function is not differentiable at x is equal to 0.